All right, welcome to angular mechanics here. Remember that when we're talking about angular mechanics, we're talking about things that are rotating. Okay, so uh, in the past, we talked about linear displacement, which was s. In this unit, we're going to be talking about theta, which is angular displacement, right? Okay. Now theta can also be positive and negative, just like s can be, right? So it's basically just like linear kinematics here, right? So we can imagine some amount of angle like this, right? Okay. Normally, theta is, we should do it in radians. That's sort of the party line, but there are other units of angle that we could use, right? Okay. Um, and then if we divide these by t, we get s divided by t is velocity, and theta divided by t is omega. This is angular velocity. Okay. And that's the Greek letter omega. It's kind of a round EW like that. And that should be in radians per second. But there are other units, and so that's kind of the whole point of this first section here, right? And then we could also talk about how fast something changes its velocity. In this case, the angular equivalent of that is alpha, which is angular acceleration, okay? And that is alpha. And that was just always going to be in radians per second, okay? Now we could do this in rotations, in which case we could do also rotations per second. And then we could also do rotations per second. And that's not so bad. This is what we really should do. This is okay, right? But you know, then we can also, there are other units, right? So there's like RPMs, right? Which is an RPM is a revolution per minute. But boy, just stay away from this, right? You really don't want to deal with revolutions per minute. I mean, you can do it, but yeah, don't. Okay. So basically, if I get RPMs, I turn them into radians per second. And it's, you know, sometimes you can do the math with rotations per second. So when we do these problems, I'll show you what I mean. Okay. Um, when I hit the right arrow here, whoa, look at that. Okay. Here are some of the unit conversions, and I think you're familiar with these, right? To turn radians into, and turn revolutions into radians, just multiply by 2 pi, and that's because every revolution is 2 pi radians, right? And then if you have revolutions, or I'm sorry, if you have radians, you want to divide by 2 pi, and then just be careful. You multiply by 2 pi, you don't need the parentheses. Dividing, you definitely do. Okay, so on your calculator, say if you have 16.7 and you want to divide by 2 pi, okay, this is a fail on your TI calculator because it's going to divide by 2, multiply by pi, right? With the parentheses, it divides by both. Or you can go 16.7 divided by 2 divided by pi. Just be careful, okay? Okay, and then if you have RPMs and you want radians per second, if you multiply by 2 pi, that will give you radians per minute. And then if you divide by 60, you'll get how much it does in a second. I hope that makes sense, right? Now, if you have revolutions per second and you want radians per second, well, every revolution is 2 pi radians, so just multiply by 2 pi, right? And then if you have RPM, if you want to have radians per second, if for some reason want to turn it into RPM, which by the way, RPMs is far more common than radians per second. What you do is you take the radians per second. If you multiply by 60, that will give you radians per minute, right? Okay, and then if you divide by 2 pi, that'll give you revolutions per minute, okay? In the next few videos, we'll bust out some of these conversions, okay?